Assalamualaikum warahmatullahi wabarakatuh and have a nice day. My name is Muhammad Azrul bin Malatif. My number matrix is A21A3313. Okay, for my part, data description, descriptive and summary statistics. We got 6 different variable name and measurement. For variable name is liter per 100, ratio, KPL, ratio, cylinder, nominal, horsepower, ratio, weight, ratio, brand, nominal. Analysis, conduct, summary, statistic, numerical, descriptive, measure, graphical representation, statistic analysis using software, and theoretical modeling. Table 2 display the 392 data point for the descriptive variable value liter per 100 kpl, cylinders, horsepower, weight and breadth of car. 150 statistics for every liter per 100 kpl, cylinder, horsepower, weight and breadth are included in the sample data. 2.0 sampling data and record categorical data. It is have 392 data, but we got 150 sampling data and categorical data.
Now I want to explain about 3.0, that is a numerical descriptive measurement, which is we will measure the mean, median, mode. So first of all, we have to make a column or table with the class interval, midpoint, frequency, and also frequency times by midpoint. So for this slide, the mean for horsepower is 1.40. Finally, we have to find the median for this sample data, which is we have to create a table with the content of class interval, frequency, and followed by cumulative frequency. Okay, for our class median is 1.30 to 1.50, and for this slide, our class width is 1.22. So about 50% of the horsepower is 1.22. We have to find the mode for this sample data, which we have to create a class interval with frequency. So our mode is 1.38, which is the highest of the horsepower is 1.40 for this slide.
So the next slide about the graphical representation. From the table 3, the highest frequency horsepower is 1.30 and 1.50 from 150 sample data select for each car, while the second highest horsepower was 0.88 and 1.08 out of 115 sample data, and then the third higher is 1.09, 1.29 out of 115 sample data. The next slide show about the numerical deterioration measurer. The calculation phase is performed with use the calculation made SPSS basic, and then after the research complete the manual calculation step, we made a comparison between the computation made by hand and tools made using SPSS. So we get the data here and finding of the comparison.
I want to explain about the 5.2, which is hypothesis testing. We have two hypothesis testing, which is one sample test with the test value 1.66, and for the LP100 and also KPL chart. Okay, 95% of confidential interval of differences for the LP100 is lower 1.7058, and the upper is 2.1342, and followed by KPL chart. The lower is 1.3004 and the upper is 1.7263. 5.3 is mostly a correlation analysis. For the correlation, we have a correlation significant at the 0.01 level. So there is a correlation between liter per 100 and also kp. L, it is weak and has a negative correlation relationship. Finally, for this analysis or the test, conclusion will be if the house power value increase, the weight value will be followed suit and vice versa. Thank you.
Greetings to all. I'm Aishwarya Sugumaran and my metric number is A218238. Today I'm going to talk about confidence interval. Confidence intervals is made up 95% confidence interval for mean, which is lower bound and upper bound, which is contains 5% trimmed mean, median, variance, standard deviation, minimum maximum, range, interquartile range, skewness and kurtosis. So basically, 95% confidence interval for sample mean used Z distribution formula since sample size is more than or same as 30, where significance level A equals to 100 minus 95 equals to 5% or 0.05. Therefore, that can be concluded the limit range of liter per 100 is from 3.37 to 3.79 at 95% confidence interval. Thank you. Greetings to all. I'm Aishwarya Sugumaran and my metric number is A218238. Today I'm going to talk about confidence interval. Confidence intervals is made up 95% confidence interval for mean, which is lower bound and upper bound, which is contains 5% trimmed mean, median, variance, standard deviation, minimum maximum, range, interquartile range, skewness and kurtosis. So basically, 95% confidence interval for sample mean used Z distribution formula since sample size is more than or same as 30, where significance level A equals to 100 minus 95 equals to 5% or 0.05. Therefore, that can be concluded the limit range of liter per 100 is from 3.37 to 3.79 at 95% confidence interval. Thank you.
Hi, my name is Anissa anak perempuan Dian. My metric number is A21A2406. Today, I would like to talk about the prediction modeling. We got three tests of normality. It is LP100. For Komogorov, the statistic is 196, DF 150, significance 00. Second, KPL cat, statistic is 186, DF 150, significance 00. Third, horsepower cat, statistic is 187, DF 150 and significance 00. For Shapiro, LP100 gate statistic is 96, DF 150, significance 00. KPL cat 880, DF 150 and significance 00. And last, horsepower cat, the statistic is 92, DF 150 and significance 00. Based on the coefficient table, we can do multiple regression models. Y equal 5.592 minus 0.770 kPl cat plus 0.113 horsepower equal 4.932. Thus, for every unit increase in kPl cat, LP100 will increase by 4.932, provided the horsepower remains unchanged. Similarly, for every unit increase in horsepower, LP100 will go up by 0.113, provided the horsepower is still of the same kPl. Next, is conclusion. Little per hundred and KPL cat are the variables that had been chosen for several variables from the dataset. 150 data were randomized selected by using the SPSS software. Measures of center tendency, measure of position, and measure of variation were manually calculated. SPSS software were used to do the statistical analysis. The result of the hypothesis testing for ANOVA analysis is failed to react. For correlation, we can conclude that there is no correlation between three variables. Thank you.